Good morning. I am Remila, Assistant Professor, Science and Humanity Department, Emmanuel Arasar, JJ College of Engineering, Nattala. Now we discuss about a small topic is SI units and statics. First I will explain the first chapter, SI units. Physical quantity. Physical quantities, this is the first chapter. It is the types are the fundamental quantity, supplementary quantity and derived quantity. What is meant by physical quantities? The accepted standard value which is used for the comparison of a given physical quantity is known as unit. The units or the physical quantities classified into three ways. The first one is the fundamental quantity. The second one is supplementary quantity. The third one is derived quantity. Fundamental quantity. What is meant by fundamental quantity? The fundamental quantities are the physical quantities which cannot be defined in terms of other physical quantities. Okay, this is the fundamental quantity. Actually, the basic three physical quantities are length, mass, and time. This is the basic fundamental quantities. But in general, there are seven fundamental quantities: length, mass, time, then electric current, temperature, luminance intensity, amount of substance. These are the seven fundamental quantities. Okay. Fundamental quantities type: length, mass, time, electric current, temperature, luminous intensity, the amount of substance. Length. Length SI unit is meter. It refers as meter. Next one is mass. The mass, the SI units are kilogram. It is represented as kg, kilogram. Then time. The SI units of time is second. It's represented as a symbol is S. Then electric current. The electric current SI unit is ampere. It represented as a letter capital A. Then temperature. Temperature, the SI units are Kelvin. Okay, Kelvin. Luminous intensity means candela. Candela means the symbol CD. The amount of substance, the SI units are mole. Mole means MOL. Okay, this is the fundamental quantity. Actually, the basic fundamental quantities are length, mass, and time. This is basic fundamental quantities. Then general seven fundamental quantities are length, mass, time, electric current, temperature, luminous intensity, amount of substance. Okay. Next one. Supplementary quantity. In physics, only two physical quantities are used as supplementary quantities. The first one is the plane angle. The next one is solid angle. The plane angle, the SI units are radian. It represented as RAD. Next one is the solid angle. It is SI unit is stradian. SR, stradian. Okay. The solid angle of cone is the formula A by capital A by Oscar. The solid angle of the sphere equal to 4 pi. Next one is derived quantities. What are the derived quantities? The physical quantities which can be derived from the fundamental quantities are known as derived quantities. Some of the derived quantities are given below. The first one is area, types, area, volume, density, velocity, acceleration. These are the types. Then SI units. Finally, I will explain the dimension. Okay. What is dimension? The previous slide, I go to the previous slide and the dimension formula. The first capital letter L, M and T of the fundamental quantities of length, mass and time respectively are known as a dimension of the three quantities. The dimension of length is capital L. The dimension of the mass is capital M. The dimension of the time is capital T. This is the dimensional formula. The capital letters of length, mass, time, it represented as a simple L, M, T. These are the dimensions of the three quantities. Okay. Next I will go to the derived quantities. In a physical quantities which can be derived from the fundamental quantities are known as derived quantities. Explain the types and SI units and finally dimension formula. The area. The SI units of area is small m square. The dimensional formula for area is capital L square. The dimensional formula only explain the simple is in the capital letters. The area of SI unit is small m square. The dimensional formula of area is capital L square. The volume of the SI units of the volume is capital M cube. Okay, M cube. The dimensional formula for volume is L cube. Then density kg M cube, dimensional formula. Then velocity, acceleration, the momentum, force, impulse, energy, power. These are the another types and then SI units and dimensional formulas. Okay. Next one is the concurrent forces. What is concurrent forces? The concurrent forces are two or more forces whose lines of action interest at a single point. These are called concurrent forces. What is concurrent forces? Actually means the concurrent forces means the two or more forces acting at a single point are known as concurrent forces. Two or more forces acting at a single point are known as concurrent forces. Okay. Then coplanar forces. What is coplanar forces? When two or more forces acting on a body lie in one common plane, they are said to the coplanar, or these forces are called coplanar forces. Then types: coplanar concurrent forces, non-coplanar concurrent forces. All forces lie in same plane. Their lines of action meet at a one point is called coplanar forces. Non-coplanar concurrent forces means the force do not lie in the same plane. The force do not lie in the same plane. Their lines of action still intersect at a common point. This is non-coplanar concurrent forces. Then resultant of concurrent forces. Okay. The resultant is obtained by resolving all forces into the horizontal and vertical components. These types horizontal component, vertical component, magnitude of resultant, direction of resultant. This is the example. Then next one is the Lami's theorem. What is meant by Lami's theorem? If a point is in equilibrium under the action of three forces, then each force is directly proportional to the sine of the angle between the other two forces. This is Lami's theorem. Okay. If a point is in equilibrium under the action of three forces, then each force is directly proportional to the sine of the angle between the other two forces. Actually, it explains, consider at a point O, at equilibrium under the action of three forces P, Q and R. Under the action of three forces P, Q and R. If alpha, beta, gamma are the angles, okay. P, Q, R are the opposite side of forces. According to the Lami's theorem, the P is directly proportional to sine alpha, Q is directly proportional to sine beta, R is directly proportional to sine gamma. Then first, experimental verifications of parallelogram law of forces. Experimental verifications of parallelogram law of forces. Then explain experimental verification of Lami's theorem. Experimental verification of Lami's theorem.